Okay, I'm going to now bring in some data from a completely different source. So let's start by file open here. And I'm going to go and find myself a shape file. So ArcView shape is generally 2D data with attributes, but it's nice because, let me find my example. This is some LiDAR data that we have. There we are. Shapefiles are nice because they have projections associated with them. There's shapefiles have multiple files. I'm looking at only the SHP file here, but there's actually 4 or 5 files associated with the SHP. One of them is a PRJ file, and that is the file that contains the projection. Okay, so I'm going to open this up, and I don't need to save that. Right. So I'm going to include attributes, and I'm going to bring this into my empty terrain. But let's look at the projection. So it populated the from and to with the same projection that was built into the shapefile. These are UTM coordinates. But I have some LiDAR data, and the LiDAR data is in a completely different coordinate system. So rather than convert the LiDAR data, which would take a little bit of time, it's totally possible, and there's nothing wrong with doing that. I just don't want you to have to watch while it grinds through 5 million points. So what I'll do instead is I'll change the coordinate projection for the target, or the, we're going to call this new design. We're going to put it into, now I happen to know this number, the EPSG number for BC Albers. There it is, BC Albers. But the fact is you can look these things up on the internet, and you can even find these text strings called WKT, which stands for well-known text. One of those really annoying acronyms. Anyway, there's a lot of power here for changing projections. EPSG is a really nice shortcut. So we have some built-in projections here, Universal Transverse Mercator, United States State Plane, and a few others. But if you don't see it on our list, you can enter it with an EPSG number right here. And like I say, it's not hard to find those numbers on the internet. Okay, so now I'm converting from UTM to BC Albers, and therefore I need to apply a transformation. There we go. Now, did that work? Am I in world coordinates? When you have a projection defined, and you can look at it later in the setup, module setup projections tab, then you can always calculate lat-long coordinates from any point on your feature. So I can actually display lat-longs if I wanted to. But here's a really powerful tool that we can't show often enough. You can save as Google Earth. I've already done this, so I'll just use the same file. When you export to Google Earth, you have a choice to do all features or selected features, so you probably wouldn't want to export your LiDAR data. Here we are. I'm just going to select this one file to Google Earth. Now, it was already open, so it didn't take long to get there, but you can see we've got the black line is the line I just exported, and you can see by looking at Google Earth that, yep, there's a road there, and that is sitting right on top of it, and we can see that we're in the right coordinate system. Okay, now that I have a well-defined BC Albers line in my file, let's bring in the LiDAR data. So I'm going to, whoops, not there. Here in the home menu, insert file. And I want to open up an LAS file. I've got 2 tiles, but I could select n of them here. 2 is good enough. And when I click on this examine button, The software goes and reads the LAS file and figures out whether you've got point categorization. These files do, and they're about, well, you can see there's 79 million points in the files, but most of them are unclassified. And it's taking just a minute to reread them. Whoops. There we are. So unclassified is 76 million points. Ground points, those are the ones I want, 2.9 million points, and then a few other points of various kinds in there. I'm just going to bring in the ground points. 2.9 million, no problem. We can read all those points if we want to. But as an exercise, let's reduce the number of points we're reading. And I'm going to do that by selecting using a corridor. So I've got a feature in here. I read it in from that shapefile. Let's create a corridor that is 200 meters wide, 100 meters each side of this feature. Now, in my import options under selection, I have two regions. We'll change the default to decimate the data, read 1 and 20, or skip 19. We'll set up the corridor to read all points, so that's high resolution data. And I think that's all I need to do. There is no defined projection on LAS, so when I click OK, it says, hey, there's no defined projection here. Is this all right? Yes, it's okay. I happen to know that it's BCL Bears, and you'll see in just a minute that I got it right. LAS is a nice format. It reads in quickly. So we've gone through all 2.9 million points as of now. And you can see that we've got dense data near the road feature and less dense data outside. And the point count down at the bottom screen is showing me 500,000 points total. Well, I've got very dense data here. The points are practically one on top of each other, and this is typical of LiDAR where there's no canopy. So the roadway was already in existence before the LiDAR was taken, and so we got lots of extra points in there that maybe we don't need. Now, again, there's nothing wrong with working with 5 million or 500,000 points. Let's thin it some more. So we've got in our train modeling ribbon, we've got simplify, and I'm just going to take out points. What this does is it doesn't create a fixed perfect grid. What it does, basic grid simplification, is it divides the area up into 2-meter rectangles, and then it picks one point in each rectangle and says that's all I need and throws the rest away. So you'll get points that are roughly 2 meters apart if you set the grid spacing to 2. It's really fast. There we go. And you can see that now I don't have a whole bunch of extra data near the road, and my point count has gone down to 172,000. Let's just quickly take a look at that by generating the surface and some contours. I'll do contours quite far apart, so it doesn't take too long. I think we've got points 20 meters apart, sure. Okay, no labeling. Oops, I didn't mean to click on that button. There we go, there's the 3D view. Oh, when I did the generate tin, I chose spacing of 20 meters, and you can see that in my decimated area outside of the roadway, I've got holes that are actually bigger than 20 meters in size. So they're showing up as holes in the model. Let's change that to 50 and see what happens. That's better. And here's my roadway. Now that I have a surface, I can change it into a draped feature, so I'll do that here and click on Apply. And let's look at the plan. Pardon me, I don't need the profile. And there we go. So we got the plan, and we got the 3D. And if you zoom in on the 3D, you can see quite clearly that there is a roadway there. And so I know that my 3D data is lined up as well. And everything is georeferenced. And now I can peg in a road, I can draw a polygon, and I can export any of those features back to Google Earth if I want, or bring it into some other software, like, for example, ArcGIS. We do File Save As Shape. Where is it? There we go. So you can take your line work, you can export it back to shape, and it will create a projection. So that shapefile will be georeferenced, right? PRJ, that will be a georeferenced shapefile.